Hello everyone, welcome to the next lecture on the complex analysis. Today we will discuss about the concept of the power series. Myself Dr. Harish Garg. You can follow and subscribe my YouTube channel where you can find the complete lecture of the complex analysis. You can see in this playlist the properties of the modulus, Cauchy-Riemann, polar form, harmonic functions, Cauchy integral and many more lecture available in this playlist. You can also see the PY question series of the CSR net and the GATE examination also available in this playlist. I hope you can subscribe my YouTube channel. Now, what is the concept of the power series? Whenever we are dealing about the power series, the first things come in your mind is always the power series is an infinite series about the point z minus c. Here, this c is called as the center of the power series, while this is called as the center of the power series, and this c is always my constant number. Fine. While a0, a1, an are called as the complex coefficients. These are called as the complex coefficients of the power series. If you particularly take c is my 0, what does it mean? That means you can say the center of the power series 0, then the power series is defined like an z raised to power n, and again the ai's are my constant coefficients. Now, once we know this is the basic definition of the power series, the first question always come in our mind is this power series is convergent always? If yes, then what could be the center? What is the radius? And what is the interval of the convergence? Is it convergent for all those values of the z? Is it convergent only for some finite values of the z? Or it convergent only for some finite values of the c1 and c2 and so on? The third question arises here is, if it is a convergent, can you say it is absolute convergent? The answer of all these questions we will discuss in our this lecture in a full details. I hope you can like and comment on this video as well. Now, the first very special property of the power series is it either converges or absolute convergence depending upon the values of the z. The first case is it may converge for all these values of the z, or it converges only at the center, or the third case is it convergent for some finite intervals. It converges only for some finite intervals. In this particular case, you can see the center is my 0, so this condition, the z is convergent only at the center, is converted to z is 0. The meaning is, if you say this is my complex plane, fine, for all the values of the z means the power series convergent for all z. Second case is only at the center, that is my c, only at the center. And the third case is it convergent for some values from minus r to plus r. However, always remember, at the value of the z is r or at the value of the z is minus r, the power series may or may not be convergent. Now, the second thing comes in our mind is, what does this r meaning? What does this r? Because this gives you the upper and lower bound. So what does the meaning of the r? And this r is called as the radius of the convergent. In other words, how we can say the radius of convergence? You can see the power series is convergent either only for all the values of the z, or only at z is equal to c, here the center is c, or for some finite intervals. Whenever we are talking about it convergent for all those values of the r, then the radius of convergence is my infinity. If it is convergent only at the center, then the radius of convergence will be 0. While if it is convergent for the finite interval, then we will get the value of the finite r. That means there are the three cases: 0, r, and infinity. So 0 is occurring only when it has a center, r is occurring for the finite intervals, infinity is occurring only for all the values of the z. Now, here we are talking in the both the sides, we are talking about the r, that is the radius of convergence. So what is the meaning of the radius of convergence? First of all, the radius of convergence is the any positive real number. Fine. It is any positive real number such that whenever z minus c is less than r. Again, if you look about this diagram, fine, this is my center C and this is the value of C plus something. This is C minus R. This is interval. How you can write this interval? I can say this is the Z minus C is less than R. This interval is called as my convergent. That is, a power series is convergent in this interval. However, the power series is divergent for outside this interval. Fine. That means the power series is divergent whenever Z minus C is less greater than of the R. Again, as I mentioned you, the power series may or may not be convergent on the boundary points. If you know the interval of convergence, what is the meaning of the interval of convergence? We can find the collection of all those values of the Z. We can find all those values of the Z at which the power series convergent. That means we will look at all those values of the Z which satisfied by this condition. Here again the question arises is how we can compute the radius of the convergence. The answer is given in the formula known as the Cauchy-Hammer's formula. But make sure before you apply the Cauchy-Hammer's formula, the coefficient of Z must be 1. Fine. I can write for you here is the coefficient of the Z must be 1. If it is not 1, you can make them. Like if I say this is 4Z minus 5 raised to power n. So I can take 4 raised to power n is a common. Then it is a Z minus 5 over 4. Now you can see the coefficient is my 1. Then once you can make the coefficient 1, either you can use the formula of the first or the second. That is the limit supremum. This is the absolute value and this is the absolute value. But the question is when you can use the first formula and when you can use the second formula. The first formula is preferred whenever your an involves power of the n terms. Fine. On the other hand, this formula is preferred whenever your an involves factorial terms. Whenever I will explain you the examples also in this lecture. Be stay tuned till the last of this lecture. So whenever an involves the factorial terms, then you can prefer to use this formula. For example, you can see in this case, this an is my 4 raised to power n. So since it involvement of the power n, so I can prefer to use this formula. Once you can find the value of the R, you can define the interval of convergence is Z minus C is less than R and the divergence is Z minus C greater than R. And the R is known as the radius of convergence and C is the center of the power series. Again, I can mention you the coefficient of the Z must be 1. Otherwise, you can find the radius of convergence from here. Once you can make the coefficient of the Z 1, whatever you have right here, it is my radius. Whatever you have right here is the center of the convergence. For example, here. Now you can find the center, you can find the radius of the convergence. Can you compare the power series with the help of here? What is the value of the an? Your an will be 3 plus 4 iota raised to power n. How you can find the radius of the convergence? You can see it is the power of the n. So I can prefer to use limit supremum of the an raised to power 1 over n. Because there is only one term, so there is no need to write the supremum. So can you find the value of an raised to power n? So n will be cancelled out. Now what is the answer of this? Can you find the modulus value of the 3 plus 4 iota? What is the value of the x plus iota y modulus? It will be x square plus y square. So it will be 9 plus 16, 25. That is a 5. So the answer is 1 over 5. So therefore, the radius of convergence is 5. Can you find the center? You can compare the power series with the Z minus C raised to power n. Can you find the value of the C? C will be 0. So the center is 0. radius of convergence 1 by 5. And if you are talking about the interval of convergence, what is the interval of convergence? Z minus C is less than R. That is, ZC will be 0 is less than of the 1 over 5. And if you look about the graphically, it is from minus infinity to plus infinity. Center is my 0 and it is my minus 1 over 5. It is plus 1 over 5. That means your power series is convergent only in this interval, while for the outside case it is divergent. Look at one more example. Your target is to find the center, radius and interval of the convergent. Can you compare the power series with this one? What is the an? It is 1 over n factorial. Now since it involves the factorial, I can apply second formula. That is a limit n approaches infinity, an plus 1, n plus 1 factorial and n factorial over 1. So what is the answer of this? It is a limit n approaches infinity, 1 over n plus 1, n factorial will be cancelled out. So 1 over infinity is 0, 1 over 0 is infinity. So therefore, the radius of the convergence is my infinity because the coefficient of the z is 1, center is my 0 and interval of the convergence is z minus c is less than r. What does it mean? Mod of z is less than infinity. If you look about this case, what does the meaning of that? That is a minus infinity less than. That means the complete complex plane. That means the interval of convergence is my complete complex plane. Now, once we know how we can apply the Cauchy-Hammer's formula, that is a radius of convergence. So this radius of convergence satisfies certain properties. That means whenever you can find the value of the R by either of the formula, then it converges absolutely. It also converges the uniformly. Those that is a power series converges absolutely, power series converges uniformly, power series is divergence depending upon these conditions. The proof is a very simple. So I can start with this limit of this supremum example. Now first of all, what is the meaning of the mod of z less than r? That is the equation of the circle. Center is 0, radius r. Fine. This is my r. Is it okay? Now for all z less than r, I can choose any point here whose radius is say rho. Fine. So I can say there exists certain rho which is greater than 0 such that 0 is less than rho is less than r from this diagram. Fine. I can say there exists a rho such that mod of z from this diagram you can say this is the complete r. So I can say mod of z is less than r as per this condition. Fine. So I can insert rho in between them. Now by the definition of the limit supremum, what is the meaning of that? We can say there exists some number such that the value of the an raised to power 1 over n is less than of 1 over rho. Fine. Now my target is to complete the power series. I can find the value of the an. It is 1 over rho raised to power n. For all n greater than of the n naught, I can multiply both sides by z raised to power n. It will be less than of z raised to power n for all n greater than of the n naught. Fine. I need a series. I can take on the series on the both side. So what does it mean? This is a z over n whole square. Fine. Now you can see this series z over rho raised to power n is my GP series, and we all know when the GP series is convergent, and it is convergent. When it is a convergent, it is convergent only when the common ratio is less than 1, and you can see mod of z is less than r we already satisfied. So that means the right hand side is my convergent. So once the right hand side is convergent, I can use the limit comparison theorem or limit comparison test. By using the limit comparison test, this series is also convergent. What does it mean? If the absolute value is convergent, what does it mean? The given power series is my absolute convergent. So that's the required proof of the first part. For all the values of the z is less than r. Second part, whenever mod of z is less than of r, that means your target center is 0. Now in this case, radius is my rho, and rho is also less than of the r. So basically, this is my rho up to here. So that means this is my circle of the radius rho, and this is the complete is my r. Now your target is to prove is a uniform convergent. Do you remember when you can say the series is my uniform convergent? Which test you can apply? Yes, definitely you can apply the WM test. Fine. So what is the property of the WM test? You can start with the modulus value if it is less than of the series Mn, and if you prove the series is convergent, then by the WM test the series converges uniformly. Now I can apply the same concept here. Again, you can see, because this is my circle of radius rho, as by the definition we can construct the another one. Oh, sorry, this is the r is outside. This is the r is outside. I can choose another radius of this length. Radius is my rho dash, which value is greater than of this, such that the value of the an raised to power 1 over n is less than 1 over rho by the definition of the limit supremum. So again, I can find the value of the an. It is rho of the power n. I can multiply both sides by z raised to power n. So it will be z over power n. Is it fine? Also, we can see the value of the z is less than of the rho. I can say this is less than equal to rho over rho dash for all those values of the n which is greater than of n0. I can take the summation on the both side. Fine. So this number is look like say m. That means if you consider this part, this is mn. Now my target is to prove this is my convergent. How you can prove that this is convergent? Again, this is my GP series, and this GP series is convergent only when rho over rho dash is less than 1. That means whenever, because both the numbers are my positive, and you can see it also satisfied. Fine. So therefore the right hand side is my convergent. So therefore by the WM test the given power series is my uniform convergent. Look at the last case, when the series is a divergent. What does it mean? That means you can consider the radius r, and you can consider all those values which are outside this circle. Fine. So again I can choose the one another point, say again rho, which are lies between rho r and mod of z. Again by using the definition, so we can define like here. So clearly say, can you find the value of the, because my target is again to find the an z raised to power n. Can you find the value of the an from this case? So we can see an is greater than of 1 by rho. Therefore an is greater than of the 1 by rho raised to power n. Again I can multiply by a raised to power n z raised to power n and take the summation on the both sides. Fine. Now what you can again conclude, this is again the GP series. So once it's a GP series, it is a divergent. Why? Because the common ratio is my greater than 1. So once this series is divergent, by using the limit comparison test, this series is also divergent. So this is the way you can see a very simple absolute convergence, divergence, and the uniform convergence proof is given here. Now, another beautiful result is, if you have the power series an z raised to power n, second power series you can obtain by taking the derivative of this power series. Fine. If this power series has the radius of convergence r, this power series has the radius of convergence r2, this is r1 and r2. This result suggested you that both the radius of convergence are same. This is a very beautiful property. The power series and the power series obtained by differentiating, both the power series has the same radius of convergence. So that's a very simple proof. If I consider R and R dash are the radius of the convergence of, so I can apply the definitions. Our target is to prove R is R dash. By the definition of the radius of convergence, we can apply the radius of convergence on the first series, and I can apply the radius of convergence on the second series. Limit supremum. Can you find the value of the an? This number is complete my an. Fine. Now if you make this separate, it is my limit supremum n raised to power 1 over n and an raised to power 1 over n. So what is your target? If I prove n raised to power is my 1, if I prove n raised to power 1 over n is 1 as n approaches infinity, that means r and r dash are same. So my target is to prove only this result. And how you can prove that? Very simple. I can use the Cauchy's second theorem on the limit. So that means if I choose the limit, I can take an is my n. So this value will be limit an is my n. So n plus 1 will be n as n approaches infinity. So this value will be my 1. And once this number will be 1, so therefore we can say r is equal to r dash from the equation number 1 and 2. I hope you can like and comment on this video as well. Now the last question here is, can we discuss about the absolute convergence of the power series? Of course you can. The power series is said to be the absolute convergent if the absolute value of the series is convergent. And we all know if the original series is convergent but the absolute value is my divergent or not convergent, what does the meaning? That is called as the conditional convergent. The result of this series is whenever you can say the power series is convergent for some value of the alpha, then it also converges absolutely for all these values of the z which is less than of absolute value of the alpha. Similarly, for the divergent, it is greater than. The proof is known as the Abel's theorem. This result is known as the Abel's theorem. That means when the power series converges absolutely for all these values of the z. How you can prove the absolute convergent? That's very simple. I need to prove this is my convergent. Fine. So let's start with this one. Since the given series is my convergent, what does it mean? If the given series is convergent, then this value will be my 0 as n approaches infinity. All of you know that whenever you can say the series is convergent, what does it mean? Limit xn is my 0. But make sure converse is not true. Converse is not true. Fine. Now, so that means the nth term an z raised to power 0 n is why is z 0? Because this series is convergent at z naught. Then what is the meaning of the absolute? We can see there exists a positive m so that it will be bounded. So what does it mean? I need to find the value of, so I can say this number will be less than of m over z raised to power 0. I can multiply both sides by z raised to power n. So it will be m z raised to power n over z0 raised to power n. I can take the summation on the both sides. Now clearly say this series is my GP series. Fine. Now once this is a GP series, what you can say, this is a convergent whenever z is less than of z naught. And whenever this series is my convergent, by using the limit comparison test, the series on the left hand side is also convergent provided mod of z is less than z0. Hence, the given series is my absolute convergent. Fine. So you can see that all these answers are given in a very simple manner. I hope you can like and comment on this video as well. We will see the next lecture on the how you can solve the power series, that is the radius of the convergence. How you can find the radius of convergence more in this next lecture. Till then, you can share this video with your friends. Best of luck, students. Happy learning.